Hey guys, this is Mrs. Harvin, and this is Algebra 2, Lesson 1.9, Absolute Value Inequalities. So in the previous two lessons, we reviewed just absolute value, and then we reviewed inequalities. Now we're going to take a look at these two things together. Our objective for today is this. You, the student, will write an absolute value inequality as a compound inequality, then solve and graph. So we've got three main things that we're doing. Writing absolute value inequalities, solving them as compound inequalities, and graphing those compound inequalities. Now, compound just means more than one. And so we're going to do what we did when we solved inequalities before. We're going to break these inequalities apart into two different inequalities, solve them, and graph them separately. Our life application is this. You, the student, will develop accurate algebraic skills that will be the foundation for his or her math success. So we're working on building this foundation so that as we continue throughout the course, you have the skills that you need to be successful. Let's review absolute value really quickly. We know that the absolute value of x equals 3 can be interpreted as x is 3 units from 0 on the number line. That can be 3 units to the right or 3 units to the left. So x is either 3 or negative 3. The absolute value of x is greater than 3 describes all the numbers more than 3 units from the origin. So if we draw our origin here, and we have a 3, all the numbers greater than 3 spots away from the origin. So it's going to go this way for those 2 points, anything more than 3 spots away. X is less than 3 describes all the numbers less than 3 units away from the origin. So again, if we draw our origin of 0, and we say the absolute value of x is less than 3, then it's going to be the digits that are less than 3 spots away from the origin. So that's going to be 2, 1, negative 2, and any fractions in between those digits. Let's take a look at some examples here in a minute. The solution to an absolute value inequality can be written as a compound inequality. Remember, that means we're just going to break it apart into 2. So let's take a look at this problem. Solve the absolute value of x is greater than or equal to 2 and graph the solution set. Well, we know greater than or equal to means it's going to be all of the numbers that are more than 2 units away from the origin. So this would be 2, 3, 4, 5, 6, and negative 2, negative 3, negative 4, negative 5, and continuing. So the first thing we're going to do is write that as a compound inequality. We're going to write, first of all, x is greater than or equal to 2, and x is less than or equal to negative 2. We know that negative 3, negative 4, negative 5, all of those will be less than negative 2. Remember, when we're dealing with negative numbers and inequalities, we have to flip that sign, and that is exactly what we did. When we graph that, here's what it looks like. Greater than or equal to 2, greater or less than or equal to negative 2, and all of those numbers are more than 2 spots away from the origin. All right, let's solve. The absolute value of 2x minus 7 is less than 4, and then graph the solution set. First, we need to isolate the absolute value on one side of the equation. It has been isolated, so then we can go ahead and write it as 2 equations. Now, you're more than welcome to split these this way. Negative 4 is less than 2x minus 7, and then a second equation of 2x minus 7 is less than 4. You can write those 2 separate equations, or you can just write it as one long equation like they have done here, whatever works best for you. We need to get that x by itself, and we're going to do that by moving our terms. In this case, adding 7 to both sides. Do the same over here. And after we've added 7 to both sides, we need to get rid of the 2 in front of the x, and we do that by dividing by 2. And what we end up with is x is less than 11 over 2, but greater than 3 over 2. When we graph that, you can see we've got this small portion in the middle. Whenever you're graphing an absolute value that has less than, you're going to have a small section in the middle. Whenever you're graphing anything that's less than, or greater than, like in our previous example, you're going to have two arrows going in two different directions. So greater than will have a greater number of lines than less than. Less than will have just one segment or one line. Here are some absolute value theorems that you need to know. If C, and C is representing any number, if C, or the number that we're looking at, is greater than 0, then the absolute value of x is less than C is equivalent to this conjunction. Negative C less than x less than C. Let's put some numbers here. Let's say that C is 3, and the absolute value is less than 3, then that's also equivalent to negative 3 is less than x, which is less than 3. Telling us what we already know, just in different terms. If x is greater than c, let's say that x is greater than 3, then we also have this equivalency. It's equivalent to the disjunction that x is less than negative c, or negative 3, or x is greater than c, x is greater than 3. Basically, what that tells us is that when x is less than c, we're going to have a conjunction. We're going to have a small segment where they overlap each other on the number line. When x is greater than c, we're going to have a disjunction, which means we're going to have two parts going in opposite directions. So that's what you really need to remember. Absolute value is less than, you have one segment here. If the absolute value is greater than, then you're going to end up with two segments going opposite directions. So that's how you can check your answer to make sure you're on the right track. Let's take a look at this example. Solve negative 4x plus 9, absolute value, minus 11 is greater than or equal to 4, and graph the solution set. Well, the first thing we need to do is isolate the absolute. So we're going to add 11 to both sides, and then we're going to go ahead and write that as two separate inequalities. Negative 4x plus 9 is less than or equal to negative 15. Notice here for the negative, we flip the sign. And, or, negative 4x plus 9 is greater than or equal to 15. We'll solve each of those individually by moving the constants so that they're on one side, dividing by that 4x to get the x all alone, and when we do that, we get x is greater than or equal to 6, and x is less than or equal to negative 3/2. On a number line, that's what that looks like. Our original inequality said greater than, so we know we should have had two different lines going two different directions, and we do. Applying the absolute value inequality theorem to cases where c is less than 0 produces some interesting results. There may be no solution. The solution may be the set of all real numbers. So let's say we have the absolute value of x is a number that's less than 0. Negative 1, negative 3 is less than negative 3. What would that look like? Take a minute, see if you can figure that one out, and share it with me tomorrow. Let's now go from the graph and see if we can turn this into an absolute value inequality. So working in reverse. There are some steps we need to follow. We can see that our absolute value is between negative 5 and 1. So we want to make sure that when we figure out this equation, we plug in some values to go back and check our work. The first thing that we're going to do is find the midpoint of this segment. And the way that we find the midpoint is adding up the two ends, the two end points, negative 5 and 1, and dividing by 2. And when we get that, we get negative 4 divided by 2, which is negative 2. We can look at it and say, yep, that's a logical answer. That is right in the middle of our segment. The next thing we need to do is find the distance. Now, we could just count how many spaces there are, but it's a whole lot easier to use this formula when you're dealing with larger line segments. So we need to find the distance from any endpoint to the midpoint. Well, when I count, I can tell it's 3, but using the formula, we take one of our endpoints minus the distance, or the midpoint. So we have negative 5 minus our midpoint. And when we operate on that, we find out that the endpoint is 3 away from the midpoint. Once we have our midpoint and our distance from the midpoint, we're going to plug it into this equation. the absolute value of x minus the midpoint is less than the distance. So x minus negative 2 is less than 3. X plus 2, absolute value, is less than 3. So let's plug in one of our values just to make sure that works. Let's take negative 4. Negative 4 plus 2 is less than 3. Negative 2, the absolute value of negative 2 is less than 3. And that gets me to the absolute value of negative 2 is less than 3. That is a true statement, so our inequality is valid. Today we worked on these things. We wrote absolute value inequalities as a compound inequality. Then we solved and graphed. We also looked at a graph of an absolute value inequality and came up with the equation based on the graph. If you guys have any questions, be sure to see me tomorrow.